Get tuple T. Tuple, suppose if T equals to, if I use 10, 20, 30, 40, there is no such method like T dot append. It is not possible because tuple is immutable. But before we compare tuple, and I already told you tuple is tuple can be created quicker than list. The reason I told you is um, tuple takes only one memory area because once you give the data in the beginning, that data is not going to be modified. Whereas list will have two memory areas. One memory area is for initial data. Second memory area is for the data which will be added in latter stages. So there will be two memory areas. So list is created with two memory areas. So the system has to search for two free memory areas to create list. So it will take time. Before we see how tuple is faster in creation than list, you can also append tuple, even though I said tuple is immutable. If you try to do this like this, it is not possible. Suppose if I take an empty tuple, I can keep on add the tuple using this way. I'll show you, but because it immutable, it takes different addresses. So here I'll create a tuple. So T1 equals to empty tuple I'll create. Then I'll take for I in range, I'll add 10 numbers, 10 to 100. Each time it is incremented by 10. So what I'll do is T1 plus equals to, means I'm appending. This way you can append, but what is going to happen, you'll see. Before that, I'll print T1 and the address of T1. So here, this way you can append the tuple, but what is going to happen, you can observe here. So now disconnected, now it will give the result. So something, what it is saying, ID. Sorry, T1 I had to give here, that is the mistake. So I'll re-execute. So initially tuple is empty, then tuple is added with item, but the thing, what is happening here, tuple is taking different memory locations. Just this, I told you already that whenever you try to modify immutable item, um, it will take new memory area and reference will be referring to that new memory area. But we were not knowing how to append the items to the tuple. So this way you can append the items to the tuple. But of course, tuple will be taking different memory areas as items are added. So this is what happening here. So when you take initially tuple T here, empty, that empty space will be pointed by T. Then when I try to add 10, then 10 is added here. 10 is added and T is no more reference to this. This is a reference to this. Now 20, if I add 20 and 10 and 20 new memory area it takes and T refers to this. So this is how the process goes on. So you can append items to the tuple using this technique. So I'm taking a loop. I'm saying T1 plus equals to I, comma is important here. Now if I don't give comma, it will be taken as integer. So it will be taken as one integer. So I have to take this as comma. I'll show you like this. Suppose if I take one thing here, suppose if I take T1 equals to 1. So T1 equals to 1. You may be thinking that it's a tuple. So what is going to happen here? T1 type T1 will check what is happening here. So if I execute this, now this is integer, it is not a tuple. So if you add comma, then Python understands that it is not one item, it is collection of items within brackets. So now it is assumed as a tuple. So that's why comma is given here. So when I don't give comma integer, it will take first as integer, then it will keep on add integers to it. So that is the reason why we have to give comma. So for example, suppose if I remove comma, so that is what happens. So it is not allowing for addition because can only concatenate tuple, not into tuple. So T1 plus this is now not a tuple, it is considered as integer. So it cannot append tuple. So I have to take another tuple to append. So that's why I'm taking comma. Here you have understood that if I don't use comma here, T1 is that value is considered as integer. If I take comma there, then it is actually a tuple. So that is the reason why I'm adding comma here. So now I can keep on add items to the tuple by using this way, but in fact, the tuple remains immutable. If you try to modify the tuple, it will occupy new memory location. This is one point I have missed along with the tuple. So that's why I wanted to give this. So you can always append, but by not violating the property of immutability, it will be occupying different memory location. So that is first thing. Next, I told you tuple is created faster than list. If I take same data, I told you, you can take same data and you can make it as a list or tuple. So I'll take some data like I'll take L1. L1 equals to, I'll take mixed mode data, means heterogeneous data. So I'll take some cricket score, like I'll take player Kohli. So I'll take the number of test matches played. Suppose the number of runs scored. Suppose of centuries made. Suppose if I take 27, the average score, suppose 56.66. So this is, I'm creating a list. So the same thing, if I want to make a tuple, what I have to do, just change the brackets. That's all. Other then it remains tuple. So I'll take here, just to have a different name, I'm giving T1. So I'm creating this. Now, how much time this will take if I use on this simple data, we may not differentiate much between the list and tuple. So what I'll do is I'll create this some 10,000 times or more than that, in range. So I'll create this several times. So 1,000, 10,000, okay, 10,000 times I'll try to create. So I'm creating this. So I'll create the same data 10,000 times with and that data is list. Similarly, I'll create same data 10,000 times, but instead of list, I'll create tuple. Here my aim is just to create, nothing else. So here I'll take, because I have to create tuple, I have to change the brackets. Now we'll check what time the first one takes. Both are doing same thing, same data, same number of times it is created, but one is list, another is tuple. So if I take here to know the performance, so I should know the time it. So I'll use time it, percentage time it. Here also I'll take the same thing. So it is taking 778 microseconds. So this is taking 275 microseconds. See, nearly 3 times the creation of tuple is faster. So same data 10,000 times I'm creating, same data 10,000 I'm creating. This is list and this is tuple. I'll try to increase more. We'll see the difference. So it is taking 7.66 milliseconds. So here also same number. I'll execute this again. So it is taking 2.76 milliseconds. So it is again 3.3 times faster. So creation of list is 3 times slower than tuple. The reason I told you, tuple takes only the data which remains same during the entire course of the program. So in the beginning itself, while we create the tuple, Python knows that it requires some fixed area. But whereas list requires extendable area. So the area whatever it gets, whatever it gets may not be at one place, it will be at different places. So it has to create two different areas. One is to hold the initial data whatever we create. Second is to hold the data which needs to be extended. Second is the area where extended data is kept. So because it has to maintain two different areas, it has to create two different memory areas. The system has to search for the areas, so it takes more time. Whereas for tuple, it knows that it is not going to be changed. If at all changed, it is taking different area. So the area to create a tuple is fixed, so it takes less time. So you can observe here, tuple is created 3 times faster than list. So our based on our requirement, you have to go for either tuple or list. Both are doing same thing. They hold a series of data items, but if you want a collection where in the program you are doing a lot of modifications, then go for list. You have a collection where you don't do a lot of modifications, same data you will be using repeatedly for some purpose, no modifications will be there, then in that case go for tuple, because tuple is created faster. When modifications is required, tuple cannot be used because tuple does not allow modifications. Then its performance degrades because it has to take new memory area each time some modification is made. So it performance degrades when modifications are there, because when you do modification like this earlier example I have given, where you can still modify tuple, but it takes new area. So if modifications are there, blindly go for list. If no modifications are there, blindly go for tuple. So this is how you have to choose the collection. So that is about list and tuple. We have seen some programs already on list and tuples. We'll see further programs if required on list and tuples, but we'll go ahead with the next collection, which is set. So we are going to see the next collection. So we are going to see the next collection, set. So I gave about different collections like list, tuple, and dictionary. List, tuple, set, and dictionary. Dictionary is entirely different kind of collection. I told you in the beginning, but list, tuple, set are almost same collection. I gave the comparison between list, tuple, set that time. Now I'll just give what is set. Set is a collection. Collection of first property is unique data items. So this is the first property, unique data items. So no duplicates are allowed in set. This is one property. No duplicates are allowed. In list and tuple, duplicates are allowed. So that is one thing. Second property of set is it is unordered. That means if I give list 10, 20, 30, if I give tuple like 20, 30, 40, each time, as long as I don't explicitly modify the order, it remains in the same order. Suppose first I have created 50, so it remains 50. Second I have added 20, it remains in second position. But in case of set, if I add 20 first, 10 next, 30 first, when I try to display them, it may not be in the same order. It is in a different order. So order, whatever in whatever order you add the data items to the collection, It will not be maintained in the case of set. Here ordered does not mean sorting order. The order here means the order in which you add the items. So I may be adding items to list and tuple in particular order, but whenever I try to use them or display them, it will be in the same order. Set, it is not sure. Why it is not like that? Why it is like that? It is actually out of scope of this particular course, because it is something related with hashing. Hashing is a technique related with data structures. If we will not be learning any data structures here. So it is something related with hashing technique, because while data items are added to the set, it uses hashing. So hashing does not maintain the order. That's why it is unordered. So what is hashing, you can explore. But the important point related with the set is it is unordered. The third thing is it is unindexed. No indexing is followed here. So in case of a list, this will be with index 0, 1, 2. But in case of tuple, this is 0, 1, 2. Some indexing, every item is associated with index. But in tuple, no indexing is allowed, and no indexing is part of the set. So if I try to refer, because the order we don't know, so if I try to refer first item, I cannot get. So it is not indexed. Indexing you cannot apply with the set. That is one more point to note. The next property is it is mutable. You can modify the set. So the next point is it is mutable. You can modify, not like tuple, it is like list. You can add, delete items because it is mutable collection. And tuple is represented with braces. So list is represented with square brackets, tuple with parenthesis, and set is represented with flower brackets or braces. That is one more property. Next is one more thing. What you can do is, because you set the name, it is taken from mathematical sets. So you can perform the mathematical set operations like union, intersection, difference, all those things you can perform with set. So that is one more reason why set is efficient. And because one more point to note is, because set uses hashing, it is the fastest searchable collection. Fastest, this we'll see with some like creation. We have seen how tuple is faster than list. Now, as far as search is concerned, if your aim is you have data which will be modified, but searching is our main criteria, so you can go for set. So fastest searchable collection. It is very fast. We'll see how fast it is compared to list and tuple later, but first we'll perform some operation. So it is fastest searchable collection. That is, this is about set. So we'll see. So it is if you take just once again, it is unique collection, it is unordered collection, it is unindexed collection, it is mutable, and it uses braces to create, and you can perform mathematical set operations like union, intersection, difference. You can perform, and also the search is if you take collections, the fastest searchable collection is set. So if we have data which can be, which needs some modification, but rarely we modify, but mostly we do searching, then set is the best collection. So we'll see some demos on this. So I'll take sets here. So we'll create a set first. So S1 equals to flower brackets, suppose 10, 20, 30. So this is a set. I'll add more, just I want to add more. 40, it's not necessarily order. Suppose 5, I'll take 25. I'm giving this order. Now if I print set, so it is not sure that, see, the order whatever we have given, it will not be same. So that is one property of set. It is unordered. Suppose if I take same thing as a list or tuple, always the order is maintained. So I'll take a list with same data L1. So now if I print, any number of times you use it, it will be same because it is ordered. So print L1. So if I print, the same order will be there. Sorry, to exclude this. Now I'll exclude this. Same order is maintained. Suppose if it is a even tuple, the same order is maintained. So whatever order we have created, in the same order, the data will be there. So tuple also it is same. But in case of set, I'm giving 10, 20, 30, 40, 5, 25, but it is giving 5, 40, 10, 20, 25, some order. It is not random order. If it is random order, it should get a different order each time. But each time, as long as I don't modify, each time the order remains same. So there is a hashing technique which will generate the order. So that is the reason unordered here means whatever in whatever order we give the data to the set will not maintain that order. It will maintain its own order. So that is one property of set. Another property is, suppose if I take print S1, because it is unindexed. So S1 of 0. If it is list 1, 0, you will get 5, but 10, whatever you have given. But here it is not indexed. So it says subscriptable. Subscript or index, both are same. Set is not subscriptable, means you cannot apply index on set. Once we cannot apply indexing on set, so you cannot do slicing. So here, once it is not indexed, so you cannot also do slicing. No slicing allowed here, because no indexing, slicing depends upon index. So no slicing for set. So index itself is giving error. If you try to apply slice, then also it will give error, because slicing is extension of indexing. So it is not subscriptable. It is not allowed. So that is second property of one more property of set. Now, if I take set here, I'll I'll add one more item, duplicate item. So 10, 20, again 20 I'll add, but it will not, it will ignore it. It is accepting here, it is not giving error, but it will take only 120 because it is unique collection. See, the order remains same. 20 it is not taking because it is unique collection. If you give multiple times the same value, it will take only one copy. So it is ignoring the duplicate value. So that is one more property of set. Set is unique collection. If you try to have duplicate values, it will not allow. So that is one more point to note. Next is when I take, suppose if I take list, if I take L1, if I give empty brackets, it will remain list. So if I say print L1, type L1, so it says it has a list because I'm giving square brackets. Next, if I take a tuple T1 equals to parenthesis, empty parenthesis, if I try to print the type of T1, it will give tuple. Now, how we are creating set with braces or flower brackets. But if I try to give empty flower brackets, it is not going to be a set. So that is that point I want to give to you. So that's why I'm taking this example. So now if I say print type of S1, it is not tuple, it is not set, it is dictionary. Dictionary is also created with flower brackets, so it will not be empty. Suppose if I take one value, then it will become a set. It will become a set. So if you try to create empty set with flower brackets, it will not be set, it will be dictionary. So I'll take this and I'll create with at least one value, it becomes a set. Same thing I'm taking. I'll give one value. So it is a set. So if you want to create empty list, I can take empty square brackets. If I want to create empty tuple, I can take empty parentheses. But if I want to create set, empty set, I cannot take empty parentheses, but I can do this way, set, just write set there. Then set empty parentheses, I can say type S1. Now it is a set, empty set. So if I want to create empty set, I have to use set, the keyword set, not empty flower brackets. If I use empty flower brackets, it is going to be dictionary. So this is one point to note. Then we'll see the next point, fastest searchable collection. It is mutable, that we'll see. Then, so I have some set. So I'll take this set again, whatever I have created in the beginning, I'll take it. So I'll take this set. So set, it will not allow duplicate items, but you can modify because it is mutable. So if I say print S1, so it will take only 120. Now, if I want, I can add new item. So I can say S1 add. I can add new item by saying add, not append, because append adds item at the end, but order is not assured in case of set. So there is no append method, there is add, but where it is added, it depends on hashing. So I want to add item, suppose 15. So it will be added, but where it adds, we don't know. But there is a logic behind that. It is not a random thing. With some technique only it does it. So that the order, as I told you, it depends on hashing. So 15 is added somewhere in the middle. So I'm adding now after several items. So it is added somewhere in the middle. So I can add the items to the set because set is immutable. Similarly, I can remove. So I can say S1 remove item by giving item name. Suppose if I remove 40, so I'll remove whatever some item. So I'll remove 40. Now I'll execute this. It is removed. Now I'll display the items, print S1. So 40 is removed. So you can do my additions and deletions in set, but there is no sorting here because list set is not ordered one. So there is no question of sorting. But if you want sorted order, but you can get it in a different form, but you can apply sorted function. So you can say sorted, but I'll not get set because that set will not assure you the order. So I'm saying sorted S1. So I have to give one more bracket. Sorted S1. So I'm getting the order, but what type you are getting, you can observe it is a list. I cannot get the sorted order in set because set is unordered, so I cannot maintain that order. So, but if you want the set to be sorted, you can sort it, but the result you will not get in set form, you will get in list form. So if I take this, suppose S data, sorted data will be stored here. But if I print the type type of this, it is not surely a set, because set cannot maintain the order, it is a list. So the sorted data, whatever we get from set, is a list, because set it cannot maintain order. So we cannot have a set with sorted order, because we are not sure what is the order it is going to follow. So if you want the data items of this set to be sorted, but you can sort them, but the result whatever you get is not in set form, it is in list form. So that's what is happening here. When I try to sort S1, I'm getting the data in list form. The data is sorted but not in set form, it is in list form. So you can do modifications, but not even reverse is not applicable, because reverse also follows some order. So you cannot do reverse of set or sorting of set, but you can do some mathematical operations on set. So if I take the we'll see the mathematical operations on set, like mathematical set operations, or I'll keep it as part of set. I'll not take the heading. So when you take the mathematical set operations, you can use the method of set. So what are the mathematical operations allowed? So there is intersection. Like what if you know the set operation in mathematics, same thing is applicable here. Normally we do it with Venn diagram. So suppose if you have set 1, set 2, you can take a union of them. So union operation you can perform in 2 ways. The method, this is set operation. So the method that is there in set class is union. So there is a method union. You can apply the method, and or you can use some symbol which is operator. The symbol is this symbol, pipe symbol. You can do the ORing of set, or this is OR operator. You can use this OR operator. Similarly, when I take intersection. So with the same name, there is a method intersection, and you can use ampersand for intersection. You know what is intersection and what is union. So this is, if you don't know, just I'm giving this is intersection, and the union is a combination of both. You can also have subtraction. Set subtraction means subtracting one set from the other set. So for that there is a difference method is there, or you can use minus symbol. So this is suppose S1 minus S2. This is S1 minus S2. So you can whichever elements that are there in S1 but not there in S2 will be S1 minus S2. Then similarly, there is one more symmetric difference. So I don't know the set operation name there. There is a symmetric difference method present. Symmetric difference, and it is represented with the caret symbol. What it will give is symmetric difference is, I'll give in the form of Venn diagram. It is this is the symmetric difference. So whatever I have represented in set 1, the items that are there in set 1 but not there in it is actually, you can say S1 union S2 minus S1 intersection S2. That way you can do it. So this is a symmetric difference. So S1 union S2 minus S1 intersection S2 will get symmetric difference. So this is represented with the caret symbol. So now we'll take one example here. We'll take one example. So I'll take something like something like a batsman. one set. So suppose if I take Kohli, Rohit, suppose Rahul, then suppose Pant, suppose if I take Ashwin, then suppose Jadeja, I'll take one more here, bowlers. Take bowlers, I can take Shami, then Bumrah, Ashwin, then Jadeja, then Sundar, then Shah. If I take this, I have set two sets, so I'll execute this. Now I can create a set called players. I can create a set called players from batsman. So I can take batsman union. So I can use the method union and bowlers. So by combining this, I can get the set of players. So if I execute this, if I print this, I'll get there will not be any duplicates here. So I'll get the set of players. So I'll get all players who are there. So this I can also do the same job with here I'm using the method. I can also use symbol. So I'll take just to indicate that I'll give a different name, players list. I'll say players list. So what I can do is instead of method batsman, I can use this symbol. So this symbol I can use, which is pipe symbol, bowlers. So if I do this, I'll get still same thing. So either I can use this method union, or I can use the operator, pipe operator or union operator. So now if I say print players list, I'll get same result. So I can do it either with method or symbol. So this is union operation. Similarly, I want suppose I want specialist batsman. Sorry, I'll first I want all rounders. Suppose if I take all rounders, so I can use intersection of the batsman and bowler. So batsman, I'll use the symbol ampersand to get the intersection. So bowlers. So this will give the intersection of the two, and we can get the all-rounders list. Print all-rounders. We'll get all-rounders here. So Jadeja, Ashwin, and Sundar are all-rounders. So that is intersection of bowlers and batsmen. So I can also use in place of this. I can also use intersection. I can say intersection. So I'll get the same result. So I'll get the same result. So either I use that symbol or method intersection, both remain same. So so we have seen some methods like we have seen the operations like union and intersection. Now we'll see the subtraction. You can say minus here. So if I want specialist batsman, so batsmen who are specialists in batting, not all-rounders. So I can say batsman minus So, or I can find the difference minus bowlers. So I'll get a specialist batsman. When I say batsman minus bowlers, whoever are there in batsman set, not there in bowler set, that means all rounders are removed. So I'll get a specialist batsman. Some spelling mistake. So specialist batsman. So if I print this, I'll get only batsman. Some special specialist batsman. Okay. Link mistakes. Now I'll execute it. Print SP. So here I think it's spelling mistake. So I'll get a specialist batsmen like Rahul, Kohli, Pant, and Rohit. They are not all-rounders, so I'm getting specialist batsmen. So I'm getting here with the minus symbol, or you can also do it with the difference. So if I take specialist bowlers, I'll say specialist bowlers. So I'll take here bowlers difference. So difference or minus both will fetch the same result, but I'm subtracting bowlers from batsmen from bowlers, so you'll get specialist bowlers. So I have to print it. Print specialist. So I'll get all specialist bowlers, not all-rounders, all-rounder bowlers. So Bumrah, Shami, Chahal, I'm getting. Next, I want all specialists, not all-rounders. So if I want all specialists, I can go for symmetric difference. Symmetric difference or this symbol. This is actually caret symbol. So I can go for one of them. So I can take, I can say specialist players. So not all-rounders. If I exclude all-rounders, which are intersection, I can say batsman. I can use symmetric difference, or I can use the caret symbol. So I'll use the caret symbol. So where is that symbol? Yeah, caret symbol is here. So bowler. So I'll get excluding all rounders, I'll get everything, everybody. So I'll execute this. So bowlers, batsman. So spelling mistake again here. So I'll get specialist players. So I'll get excluding all rounders, I'll get everybody. So specialist players, I can get it not with the symbol. I can use symmetric difference. So symmetric underscore difference. I can use this method to get the same effect, to get the same result. So which is specialist players. So this kind of operations, mathematical set operations, which are very useful when you are doing some kind of problem solving, it will be very useful. They are very efficient and you can get the result in simple way. So these are these some mathematical set operations like symmetric difference to find this part which is S1 union minus intersection will give you the symmetric difference. and there is difference, there is union, there is intersection. These are the mathematical set operations you can perform using sets of Python. So this is one more specialty of sets. So we have seen different operations, mathematical operations, which you can perform in a simple way using sets. So when you take the set operations, we have seen the specific characteristics of sets, like mathematical set operations, mutability, unindexed, unordered, and unique collection. Now we'll see fastest searchable collection. Which one is the fastest searchable collection? So I'll write the heading here, fastest searchable collection. So what I'll do here is I'll take simply a series of numbers, very huge numbers in all three. Same set, same thing I'll take. L1, I'll take range, list, range 1 to 10, 1,000, 10,000, 1 lakh, 10,000. I'll have 10,000 number, 10 lakh numbers. Okay, 10 lakh numbers from 1 to 10 lakh in the form of a list. From that, I want to search. Okay, then I'll take a tuple with same thing, same set of numbers, but I'll take tuple. So I'll say tuple. So take the same range of numbers. Same, I want to have even in set also I want to have, but because I'm taking a set of numbers, range will not give the data in the required form. So I'm converting into list, tuple, and set. Now all three are having same data. So what is the data we have? 1 to 10 lakh numbers. Now I want to search for a particular item in all the three. So item, I want to search some item like 1, 2, 3, 4, 5, 6. I want to search this item in list, in tuple, in S1. I'll do it 10,000 times, because one time I may not find difference. So what I'll do is for I in range, 10,000 times I'll do it. Or okay, I'll go for 1 lakh. We'll see whether it will take more time or not. So what I'll do is I'm just checking whether it is there in the list or not. That is my requirement. So I'll use the time. I'll not print just item in L1. So I'm doing it 1 lakh times. I have 10 lakh numbers. So percentage time it. So these are the things I want to do. So first I'm creating three things I have created. Then I want some item to be searched. I'm doing it on list. It is taking more times. I think I have to reduce it. Okay, we'll see how long it will take. Okay, it is taking more time. I'll reduce the number of times the searching needs to be made. So I'll reduce it. I'll say instead of 1 lakh, I'll make 10,000 times I want to search. When this is taking more time, okay, we'll see how long it will take. Okay, I'll reduce further. It is taking more time. So I'll take 1,000 searches only. We'll see. So it is taking 1.54 seconds to search an item, whether it is present in list or not. I'll do the same search with tuple and check how much time it takes in tuple, and also I'll repeat it with set. You can observe it will do very fast in case of set. I'm doing it with tuple. Now it should be almost same time, maybe little lesser than list. So for tuple, I think it should be almost same time, but little less. Like I said, this is taking 1.54 seconds to search. This is taking 1.44 seconds to search. I'll repeat this on set. You can observe very fastly. It does searching very quickly. Within no time, it should give. See, 77.1 microseconds. 77.1 microseconds. Search is very fast. 1 second is 10 power 6 microseconds. So if you take compare with see the speed with which set is doing searching is very high. So I'll take 1.44 into 10 power 6 divided by 10 power 6 77.1 because I'm converting both into microseconds. So it is see how much faster it is. 18,677 times faster. So the set is very fast in searching because when you take hashing technique is developed for searching. Hashing, the main purpose of hashing is to make the searching faster. I told you that the set takes the technique called search to insert the numbers. So because it is using it uses the technique called hash. So the searching will be very fast in case of see here I told you I've written this hashing. So hashing's main purpose is to make the search fast. So because set uses hashing, the searching is very faster, 18,000 times faster than tuple. So you can observe, see if you want to, if you have very huge data now, even if I take 10,000 items, it will be 10,000 times I want to search. It will be less than what it is required with tuple or see it is still taking only microseconds, 801. 10 times I'm 10 times more searching. I'll do 100 times more searching. Still time required is less than it. Now it is in milliseconds. So still it is very fast. See there I'm searching the same item 1,000 times. Here I'm searching it 1,000 into 1,000 times. So still it is faster. So search is very fast in set. So if you have a huge data where a lot of search happens, then you go for set because set is very efficient for searching. So this is one more property of search. Now we'll see some one simple program. One simple program will do it. So here I have suppose a list of items like 10, 20, 30, 20, 40, 50, 25, 5, 30. Now I have this. Now I want to find the number of items which are not repeated. The number of items which are not repeated. So that is my requirement. So suppose if I take the question here is so find number of items are not repeated in a collection or list. So this is a requirement. So what if it is if it is C kind of thing, I have to find 10 how many times it appears. If it is appearing 1, I can count it. 20, how many times if it is appearing. So that is how we have to do it. But in this case, if I want the number of unique items, number of items which are repeated. So I want number of items not repeated. I don't want not repeated. Number of items which are repeated. This is my requirement. So number of items which are repeated. So if I had to do this in C style of programming, it requires so much coding. But if it is Python style of coding, what I'll do is I'll take length of list minus length of set. I'm converting that list into set, so it will avoid duplicate items. Then it will queue the set length of set of L1. Sorry, I'll execute this. I did not execute it. So it is giving 2. So 10 is repeated, 20 is repeated 2 times, 30 is repeated 2 times, remaining all unique. So I'm getting here number of items which are repeated in a collection. So what I'm doing is I'm finding the number of items in the list. So I'll do this step by step, but you can do it. So I'll take length of, so length of L1 gives the number of items that are there in the list. So 9. Now I'll convert that into set. I need not store it, just for this explanation I'm storing in a set. So what I'm doing is that list I'm converting into set. So when I convert that list into set, duplicate items will be avoided, eliminated. So if I print length of set, now I'll get the items which are avoiding duplicates. I'm getting whatever is there, that I'm getting. Now if I subtract this, so print length of L1 minus length of S1, I'll get the number of items which are repeated. So that's what we get it. Is it clear? Suppose here, okay, I'll take one more example here. So sometimes, okay, I'll if I want to find the number of items which are not repeated, number of items which are not repeated. So how many will be which will not be repeated? So my requirement here is number of items which are not repeated. This is so when I take this, so how many items are not repeated here? So when I count manually, 10 is not repeated, 30 is repeated, 40 is not repeated, 2, 50 is not repeated, 3, 25, 4, 5, 5. So 5 items are not repeated. How do you get this? So suppose if I take length of S1 minus, but see, we cannot take one set of data and say that our logic is correct to get the result. So here for this particular thing, suppose L1 minus, so I'm finding the number of unique items. I'm subtracting from set. I should get, but it is not necessarily always true. Here I may be getting 5. So for this example, it is correct. Now suppose if I add one more item, suppose if I add 20. Now the number of this, what do you get? this is always giving you the correct result. So I have, I'll check with again. Now here, this is also giving wrong result. So number of items which are repeated, here I am getting 3. So why it is working fine for the earlier example is I'm repeating any item if it is repeated only 2 times. In that case, it is giving correct result. Suppose if the item is repeated more number of times, now 30 is repeated 3 times. So the length of L1 is, if I do this, length of L1 is 10, set is 7, because that remains same, 7. So if I subtract 7 from 10, I'll get 3, but it is not correct. So the number of items which are repeated are only 20 and 30. So this whatever statements you take, it should work for any kind of data. So these statements, whatever I have taken, will not work for all kinds of data. It will work only for some kind of data. So whatever logic we are writing, it is not working correctly. So that's why I took this example. So this logic is not correct. You cannot get this for first instance. If you take this, we may think that it is correct logic, but it is not working correctly. So here what you do is take this set and devise a logic in Python, the best logic, not C kind of logic. So devise a logic to find number of items which are repeated in a collection. How many items are repeated? Similarly, devise a logic to find number of items which are not repeated. So you try this on this data, but this is failing. It works only when the repeated items are getting repeated only 2 times, not more than 2. If an item is getting repeated more than 2, so here 30 is repeated, 20 is repeated 3 times. If I remove this, now I'll get correct result. But if I add 20, then add 30 again, so only 20 and 30 are repeated, repeatedly used, but now it will give 4. So it is giving 4, but number of repeated items are only 2. Similarly, once I get this wrong, this will also be wrong, because the result, what we get, it depends on this, but I have taken the old data, so it is giving 3, but it is also still wrong. So you devise a logic to find number of items which are repeated in a collection and which are not